Alright guys, here we are today. I got a box of solenoid driver boards for Bally or Stern. We're going to go through. I got a test rig here. We're going to put them on the test rig. We're going to see if they work. We're going to fix them if they don't work. And then we'll put them in a game and I'll show you how to test them in a game as well. They're pretty easy to test and they're very important. They take a game down if they don't work. The voltages aren't right. So we're going to go through them and we're going to test them and it's going to be fun. Here we go. Okay, first thing we gotta do is put the board on the tester. Let's try this one here first. Got an X on the 5-volt voltage regulator, so I'm guessing that doesn't work. But that's an easy fix. Let's see if the rest of it works. Plug everything in. Take your time. Don't break the harness. All right, so the first thing we do when we use this tester, it can do a lot. It can test the 5 volts. It can test 5 volts is the main logic. 190 volts is displays. It tests that. And then it tests all the transistors to make sure that they're all working. And each one of these lights is a different transistor. It tells you exactly which transistor it is. On this board, the transistors are labeled. I think they are on most of the boards from this era. Okay, for instance, right here it says Q1, Q2. So that's the light for Q1, the light for Q2. All right, let's turn it on, see what happens. Oh, 16 is locked on. So when you have a light that sticks on like that, that means you got a short. So for now, we're just going to remove transistor 16 because you don't want to leave it on with a short because that can cause other problems. In this particular tester, it can, I don't actually know what it can do. It can do bad things probably. I've never left it on long enough to find out. So we're going to remove Q16 here. I'm just going to cut it out. I'll put a new one in later, but for now I'm just going to cut it out. For the purpose of testing here. All right, so I just removed Q16 and now we're going to turn it back on. All right, so it's not locked on anymore. Now we're going to go through. So far they're working. Obviously 16 is not going to work. Okay, so these two didn't blink. That means the relay for the flippers isn't working. So if I plug this in, there'd be no flippers. These two are the flipper relay. So I got to look into that. Probably a bad relay. Yeah, it should go. Oh, it worked that time. So I wiggled the relay and it worked, which tells me maybe it's like cold solders or something. I got to inspect that. But it's working now. And once it goes to 15, you should hear the click of the relay. All right, so it's working now. All right, now let's test the voltage. So I got to get my meter out. I got to set my meter to DC or direct current volts. So we can just do 200. 200 does both for the, it'll work both for the 5 and for the 190. So I'm going to go ahead and zoom in here so we can see what the actual voltages say. So for the voltage test, we don't actually need to see the back for the lights. This is all we need here. So everything's off right now, but we're going to set it to full load. We're going to test the 5 volts first, which is probably not going to work because there's a big X on the 5-volt voltage regulator, but we're going to see. What do we get? 4.7, that's actually probably good enough. 4.7 is a little low, but I think it's close enough. The game's going to work. So 5 volts works. What about high voltage for displays? 190. Let's see what we get. We're getting 176. That's probably good enough too. So with the displays, if you have a slightly lower voltage, it's probably better because it doesn't put as much power to the gas displays and is less likely to create bubbling over time. So 176 is probably enough. But There's also a potentiometer here. See if I can zoom in. And, all right, let's see if I can get it all in here. Come on. Nope. All right, there we go. So let's see if I can adjust this a little bit here. Oh, I can do it that way. All right, so that's definitely working. We can dial it into 190, which is fine, but it's probably even a little better to go a little less because, like I said, it's less voltage going to your displays, less likely to damage the displays over time. Not that in a home environment they ever get left on long enough to damage the displays, but in a commercial setting it would matter a little bit. All right, so everything works except for that transistor 16. That's nice. Let's fix transistor 16. All right, so the first part is figuring out what transistor we need. This is a close-up of the old one. The part number is X44E198. All these solenoid driver boards use the same transistors. They're all TIP 102s. But if you don't know that, you can kind of just Google this. Actually, Marco's had this listed as a comparable part number for their TIP 102s. Yeah, all these solenoid driver boards, all these transistors here are TIP 102s. That's the modern part number. And I got a bunch of them. So let's put them in. All right, so which one is it? It was 16 is this one. So that's going to be so that's these three right here. The first thing I want to do is add a little bit of solder, which got my solder right here. Add a little bit of solder. Should have had that ready. These three. Adding a little bit of solder because it makes it easier to remove it. Use this to look at that, clean. All right, now I put the new transistor in. So get my needle nose to pre-bend it here a little bit. And stick it in. Like that. Bending the tabs just a little bit so that the transistor doesn't just fall through. Let's try to zoom in a bit here. All right, for the poor video workmanship, there we go. All right. Okay, now we solder the new transistor in. And we cut off the extras with our little snippy tool. Snippy tool. I don't know what it's called. There we go. All right, now we're ready to put it back on the tester and see if it passes this time. All right. 2, 1, 5, 6, 7. We know all of them work until 16, so we're just waiting. But it's not locked on like it was before, so that's a good sign. Where'd it go? Everything's working. I already checked the voltages, we're good there. So I know what you're thinking. How do I check the voltages if I don't have a tester? Let's find out. All right, so this particular board does not have a test point for ground. And most of the time they're labeled on the capacitor. You can get a nice ground. Here's another board, for instance. See, it says plus right there. So we know this one's ground because of this, which is cheating. How else would you figure that out? I don't know. Try one. If it doesn't work, try the other one. So we're going to get a test lead here. And remember, we're just checking volts. So if you put the meter on hot and then test a test point, it won't get the right number, but it probably won't fry anything. Let's see if I can get this in screen. Oh, look, it has a test point for ground. I'm dumb. Just ignore me. This one does have a ground test point. So we're going to go ahead and set our meter. And then we're going to put the ground jumper to the black, like this. And then we're going to start testing test points. There's documentations all over on what test point does what volts. I generally don't remember which one's what, but if it's close to 5, you know that's 5 volts. If you can't find 5 anywhere, then you don't have 5, and etc. Here we go. So we're going to, oh, that's the wrong one. We turn the board on here. That one says 10.5. What is that? Oh, this one says 5 volts, so now we got a good 5 volt. So 10.5 is probably the unregulated 12 volts. That one can kind of be all over the place, and the game still seems to work fine. 5. This one gets me nothing. This one's nothing. Oh, this one's... I should have checked that. This is at 187, so we know there's our high voltage. If any of the test points give you the high voltage, then the board's probably working. So we got the 5 volt here on test point 1. On test point 2, we got the high voltage, so we know we got those 2 volts. And those are the biggest ones. This is our unregulated 12. And there's write-ups on how to test these boards. I'm just kind of doing it quick and dirty. Oh yeah, this board looks good. On to the next one. This one's got some char. But it actually looks like somebody already repaired that. Let's see here. See, these have been replaced, which is the biggest burn. So this one looks like it had a transistor probably short out, and it stayed shorted for a while, and it overheated components. But somebody fixed that already. So there's a good chance that's not going to be a problem, but we're about to find out here. Alright, here we go. Let's test the transistors. And none of it is locked on. That's off to a good start. So far they're all working. This might be a boring video if it just works. Everything's working. Alright, all transistors work. Alright, here we go. Volts. 5 volt, full load. 3.6. That's not enough. Yeah, that's not enough. Probably voltage regulator. We'll test. We'll replace the voltage regulator. See if that fixes it. What about the 190? High voltage is good. All right, so 5 volts is low. Could be a capacitor. Could be a voltage regulator. We're gonna figure it out, and we're gonna fix it. All right, so I keep on hand one of these driver boards from the later model Stern driver boards. They really label everything really well on this driver board, unlike most of them. It tells you what everything is. And it says right here, plus 5 volt. So it kind of tells you most likely this capacitor is for the 5 volts, and then this voltage regulator is for the 5 volts. So on the other board, I'm going to test this capacitor first. A lot of people will just replace them because they do go bad with age. But for now, we're just just trying to fix it. So we want to see, we're going to test it with the capacitor meter, capacitance meter, and see if it is the proper number. And if this is good, then it's probably the regulator. If this is bad, then we'll replace it. And then if it's still not working, then we'll do the regulator too. So let's go ahead. All right, how do we test it? In this particular one, somebody already cut the zip ties. You don't need to cut the zip ties to test it, but you do need to remove it from the circuit. So let's see here, how do we want to do it? I'm just going to snip it because it's pretty easy to resolder that wire. I'm just going to snip it, see what happens. Snip. All right, so now we get our meter out. You got to remove the capacitor from circuit to get an accurate test. So this meter doesn't do capacitor. I got another meter that does capacitor over here. All right, this one has capacitor, which is that symbol. So we're going to go to it, and it should be, according to this, what does it say on here? It should be 1100. So that's 1100 microfarad. That's what we want to see. What do we see? Oh, I don't know. We see. Huh? Let's see. Put this back in the video. How am I doing? Overload isn't supposed to. Is that how it goes? It looks like this thing only does up to 1000, unfortunately, which isn't very exciting. And it says that it's overload, so it's at least 1000. So I don't know if it's bad or not. Let's try the voltage regulator, see if it fixes it. All right, so we have these new voltage regulators because this old voltage regulator is a discontinued part. So there's a company that makes a new one. Let me grab it here. I'll show you. Here's a business card of the people that make it. pretty cool. They're like a little circuit board that replicates what the old one does. But yeah, you don't actually need the heatsink with these, which is kind of cool. So it's just sticking on there. So if you notice, on these, there's two holes that are closer to the screw hole. That's how you know which way it goes. It's not centered. It goes like this. And then we'll solder it on. Let's put the bolts on first. Keep it nice and tight. Let's go ahead and zip tie that other capacitor back together. It's flopping around like crazy. Enough? No, the zip tie is too small. It's all right. Zip ties back on here. Need a slightly larger zip tie, but for now this will be fine. I'm just trying to get it to stop flopping around on me. Good for now. All right, we're doing the voltage regulator. All right, see if that fixed it. All right, we got the board back on, new voltage regulator up here, and let's see if it works. 5.3, good enough. 183, we got 5 volts, we got high volts. This board's good, let's go on to the next one. All right, this is the third board. Let's see if the transistors all work. So far so good, nothing's locked on. So far they're all work. So far so good. All of them are working, look at that. All right, we're good. What about the volts? Now you can see the meter, let's just do it here. We're gonna test 190. Perfect. And now we're gonna test 5. Spot on, this board works great. Doesn't need anything. All right, now we're gonna put one of these in a game, and I'm gonna actually get the right values for the test points, and we're gonna test all the test points inside a game. So we can do this for you guys at home that don't have one of these fancy test rigs. This is a factory Bally test rig here. I think, I don't know a lot about them, but I think if you were a large operator at the time, you'd get one. You'd be able to buy one of these, but you don't see them too often. Most homeowners, enthusiasts don't have one of these. So, but you don't need one. We'll test it inside the game. All right, on to the game. All right, we're gonna try it out on this trusty Matahari. A lot of times, if you open the coin door, there's a hook inside the coin door for the key. I think this one's just not locked. To get to these boards, in case you don't know, you lift this up, move it forward. Actually, I already took the board out of this, so there's no board in it currently. We can test it. Board goes right here. Let's go ahead and put this one in. This is one of the 3 we just tested. There we go. I'm going to put the screws, 2 screws, get them nice and snug. This board in here. Screws fighting me. There we go. All right, get a screwdriver. One test, of course, is does the game boot? If the game boots and the displays work, then your board's probably good. But we're not going to take that for it. We're going to test the test points. Get the actual proper numbers from the internet instead of just winging it. Right now I'm just plugging these connectors in. Then we're going to turn the game on and see what happens. All right, so let's do that. All right, so here's the board. So on this game, and all these Ballys and all the Sterns from the era, what you want to see is this LED. Sometimes it's red, sometimes it's green. I think maybe it's usually green. Doesn't matter. You want 7 blinks, and that's the self-test for the MPU board. One of the most common things on these games is the MPU board has socket connector issues or alkaline damage, and it'll get locked on. It'll just be one solid lock, or it'll blink like twice and stop. It won't get through all the 7. If it blinks at all and the light comes on, chances are your solenoid driver board is good. Your rectifier board is good. This is rectifier board. First step is the rectifier board, then it goes to solenoid driver board, then it goes to the MPU. If your MPU is blinking twice and locking up, or just one solid bright locked on, your MPU is bad. Everything else is probably good up to that point. So we're going to turn it on. We want to see 7 blinks, and then the game's going to boot. And then we want to make sure the displays are working. We got 1. It's not blinking. All right, why is it not blinking? Find out. All right, so I got the meter. I got the clip lead on the ground. Oh, this one actually has a ground test point too. I'm testing the 5 volts, and it is not 5 volts. So I think I didn't test this board with the load on. So it showed 5 volts with no load, but it can't handle a load. So we gotta go back and figure out what happened there, because that's why it's not booting. It's got to be a locked on steady 5 volts. Probably the voltage regulator needs to be done on this one too. Let's try a different one first here. See if we can get this game to boot. All right, I got the first one that we did back in there. Let's turn it on, see if we get the blinks. 1, 2, 3, 4, 5, 6, 7. This one works. Displays are on. All right, let's test points. So a big one is you want to make sure that which we know it is because the game's working. You want to make sure your 5 volts is getting to your MPU if your game's not booting. So it's 508 nice and solid over there. I think this is half of the solenoid voltage over here. Yeah. Where's that one? Well, there it is. There's half the solenoid voltage. That's important. That's test point 3. Test point 5 should be the 5 volts. Test point 1 should be the 5 volts. What is this? Well, these are unregulated 12 volts, so that's all of them. So over here, test point 5, that's your unregulated 5 volts. It's the same. Unregulated 12 volts, sorry. Test point 1 shows a nice even 5. Test point 3, nice even 5. 7 is 5. 6 is close enough. Over here is your high voltage. Test point 2 shows your high voltage. What could be overload? Where's test point? Test point, this one over here shows 227. I don't know what that one is. But you get your high voltage, you got your 5 volts. That's all that really matters. And the game's obviously booting, so we're good. Let's figure out what was not working on that other board. Let's fix it. All right, guys. So it turns out, unfortunately, these voltage regulators I was super excited with don't actually work on this board. So I should have figured that out before I made the video. So yeah, it shows total fine 5 volts with no load, but once you put a load on, it goes down to 2 volts, which is why the board wasn't working. So let's try a different voltage regulator and see if this board will work with a different one. All right, so I talked to a friend of mine who's way better at these than I am, and he said when you install one of these, you need to remove R49 and then also remove R50, but replace it with a jumper. So here's the schematic. He said, so here's touch point 1 with the 5 volts. He said you remove R49 and you jumper R50. So I'm going to try that here and see if that fixes it. Why? Well, let me show you what's happening here. I didn't show you, did I? So you put this on the tester. Actually, to test the 5 volts, you only need this plug here. So that's all I'm going to plug in. So we got that test plugged in. We got the meter. All right, so this is actually the first time I tried one of these on this particular board, and so now I'm seeing that it works with no load. But once you put a load on it, it dips down super low. So I talked to a senior tech, and he said that when you use this particular chip on this particular board, you have to, where am I at here? It's not this one, it's this one. So here's the touch point for the 5 volts. You said you have to remove resistor 49 and jumper resistor 50. So we're going to do that and see if it fixes it. So I'll point out where they are here. This one here, resistor 49, we got to remove that one. This one here, resistor 50, we got to jumper it with just a wire that has no resistance. Let's give that a shot, see if it fixes it. It worked! Alright, so I did it. Here's no load. Back a little bit here. Here's no load, here's full load. That's good enough. Now it's not great, but so this actually has a little pot. We could turn it up a little bit. I think if we get to 4.7, I think that should work. A little high. I think it's gonna boot though. I think that's gonna work. We'll test it though and make sure. But yeah, so what did we do? That's what we gotta do apparently. We got to remove R49, which I did, and then just put a steady jumper at R50 if you're going to use one of these on a Bally Stern Solenoid Driver Board. So that didn't work. Well, works. It probably works now. We'll test it. The one that we had tested in the game earlier that also didn't work was this one. I thought this one was fine. So I'm throwing this one back on the board to try to figure out what happened. That was this one in the game. Let's figure out what happened. So we're going to, all we have to do to test the 5 volts is plug this top one in. So this one, yeah, so this one looks great. This one should work fine. Is this the one we tried that didn't work? No, it wasn't this one. It was a different one. All right. It was this one. This is the one that we tried in the first one we tried in the Matahari that didn't work earlier in this video that I thought was going to work. That was this one. All right, so let's put this one on here, see what happens. There, I got a lot of boards. All right. So I thought this one worked when I tested it. So it says 5. Oh yeah, look at how bad it dips when you put the load on. That's why it wasn't working in the game. I'm gonna try a different voltage regulator on this one, doing that same trick that we did. I'm just gonna go ahead and do it. You've seen me do it. I'm gonna do it, and then we're gonna resume when it's done. All right, we're back. Same board. All I did was remove this voltage regulator, which is bad, and the heatsink, which is no longer needed on this board. You can leave the heatsink in, but I didn't feel like it, so I took it out. So yeah, exactly. We did the hack. Remember, not the hack, the mod, the thing you got to do if you're going to use one of these easy SBCs. You got to remove resistor 49. You got a jumper, resistor 50. So you got to remove resistor 50, and you got to put a solid piece of wire in there. So you're just jumpering it, and then it seems to work fine. So I learned that trick. I didn't know that. I've used them on other boards, but on They work on WPC, which is some of the most popular games. But you got to do this mod for them to work here. I can't speak to the other games, but that's what you got to do for these early Bally Stern driver boards. You got to do the mod. All right, what are we doing? We're on 5 volts. Turn the load on. Perfect. All right, I'm going to throw this back in the Matahari. Remember, this was the first board we tested in that Matahari, and that light wasn't blinking on the MPU, and we put the meter on it, and it was going all kinds of crazy. That was because the voltage regulator was bad. So far we've replaced 2 voltage regulators and 1 transistor to get all 3 of these driver boards working. We got this one working. Yay! We got this one working. Yay! And now we got this one working. So we're going to throw this back in the Matahari and then make sure it boots and functions, and then we're going to call it good for this video. All right, I got the board installed, and all we did to this board was the voltage regulator and the mod where we removed resistor 49 and jumpered resistor 50, very important. It was very frustrating. I tried this board a few times without that mod, and it tested fine with no load, but once you put a load on, the voltage just went all crazy. It dipped down to about 2 volts. Yeah, and I didn't know why, but my friend told me to remove resistor 49 and jumper resistor 50, and now I'm going to do that, and I know how to do them. Anyways, let's turn the game on. Oh, there's no power. Turn all the games on. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 7. Displays. This game is working. This voltage regulator is working. The board is working. So we officially fixed 3 solenoid driver boards. Yeah, that's pretty good. Anyways, none of the capacitors were bad on any of the boards. So yeah, voltage regulator, that was it. And then the transistor, which was obvious. Cool. All right, so today we went over 3 solenoid driver boards. We played with these easy SBC replacement for, oops, what was it? For the LM323K obsolete voltage regulator. They make these new ones, but you got to, on this particular board, you got to remove, like I said, R49, jumper R50, and then they work. So they're a good alternative to throwing the board away and getting a replacement one. A new one of these is about $100, maybe 150. I don't know. I'd have probably about 150. So it's not the end of the world, but I like original because original is cool. They're also tend to be easier to work on. The transistors are often surface mounted on the reproductions, which can be a lot harder to swap. These are nice big, and there's a lot of resources for how to fix these boards, where the new ones are all kind of different. The new boards are great, don't get me wrong, but if I can fix an old one without putting too much money into it, I'm happy. And that's what we did. We fixed 3, so now I got 3 working boards, and we made a video. All right, keep flipping.